Hi and welcome to this RIPEX2 tutorial on Babel protocol. This is part C of our series where I will show you how to use Babel in a network featuring fast backbone like Ethernet or optical fiber. We will be using the same topology and base configuration as in parts A and B, so I would recommend seeing those tutorials before attempting this one. For this tutorial, we will need to simulate a very common situation when units don't hear each other without a repeater. To achieve this, in our bench test, we will use a frequency pair. Unit A and D will send on 400 MHz and receive on 415 MHz. Units B and C will send on 415 MHz and receive on 400 MHz. In case your RIPEX units are in another frequency range, please configure them accordingly. In case you prefer going straight to this one, you may download starting configuration files from a link in the description. One feature that really makes Babel stand apart from other dynamic routing protocols is its ability to work with both wired and wireless connections differently. In this tutorial, we will connect Unit A and B with Ethernet, simulating fast wired backbone. Radio channel will be used to connect the radio-only stations and as a backup route in case of backbone connection failure. Let's start configuration of Unit A. Go to Settings, Interfaces, Ethernet, and create a new network interface. Name it Backbone and select Ethernet 4 port. Leave Unit Management active and add IP subnet of 192.168.101/24. Then go to Settings, Routing Babel and select the Network tab. Add a new interface called IF Backbone of type wired with RX cost of 10. This ensures a wired connection will have priority over radio. The advertised next hop is 192.168.100.1, which is our new Ethernet 4 IP address. Now, you may review the configuration and set it to the unit. Unit B has the very same configuration, only the network interface has IP of 192.168.100.2/24, and the same is used as advertised next hop in Babel. Make sure RX costs of all radio links in the network are set to 100 and power cycle all units. Log in back to Unit A and go to Diagnostics Information Routing Babel. Unit A sees its neighbor, Unit B, 192.168.2.0/24, using both radio and IF backbone, but will use the backbone since it has much lower metric. Also, see connection to Unit D at 192.168.4.0. Babel correctly selects route starting via Ethernet to Unit B and then via radio, thus avoiding one extra radio hop. Let's confirm our network is running as it should with a combination of diagnostics tools. Connect your laptop to Unit A port 1, 2 or 3 and send its static IP of 192.168.1.10/24 with a default route to 192.168.1.1. Go to Diagnostics Monitoring and enable monitoring on Ethernet 4 and radio and limit monitoring to only ICMP. Save settings and start monitoring. Then use your computer terminal or command line to issue a ping command to 192.168.4.0. See monitoring recording traffic over Ethernet 4. Now, unplug Ethernet cable connecting Unit A and B and see Babel switching from Ethernet to radio channel. Also, if you see Babel Diagnostics now, our IF backbone should have a metric over 65,000, indicating a broken link. In this case, radio will be used. Babel traffic may also be seen in Diagnostics Statistics by selecting Ethernet Statistics and scrolling right to IPv6 column. And that is all I have for you today. Please see Babel tutorial part D, which combines radio with cellular. Thank you and have a great day.